think we will be going online. So yeah, so now we are officially starting the third day of our synthetic intelligence workshop. And again, I'm speaking at the background with my video. So super nice to see everybody. Hello, Artem. I think Artem is also joining us. So yeah, Artem, we already started the short discussion about the results of the work that guys done. I think there is a good work happening, and of course there are some questions. So I propose to start the session today from some maybe question answer time that we could check if anybody has any problems. You could share with us anything that you have that you've already done, share the experience, thoughts. So, and after all, we come to the second step of the working with the coding that Artem will introduce in a bit. Yeah, what do you think? Will it work?
Yeah, I guess it's a nice plan. Who wanna start with the questions or showing the results that you get?
Gabriela, do you want to begin again and show to Artem the results and give him your questions that we started already?
Yeah, sure. So I was telling that I have like this result, but I also have like few questions. One was about someone else also question that made this question in the WhatsApp chat, that how we can train like our or make our own model, not using like this flicker faces model, and you already answered, but I'm not being like completely sure about what does it mean or how does it work. And then I have few questions, like for example, some parameters that there that we have in the last notebook, in the generation one, about first. I think we are going to review this today, but you say something about the seeds, like the seeds that we use in some of these cells. Like for example, in the generation, we have to decide which cells we want to make, but I'm not completely sure what does the seed mean. Like if the seed is a reference to one image, like for example, we use 42, 3000 something, and then 80. And my question is if we are like using this index about we are using the index or we are trying to ask like to give us back the 42 image from all our array, and then we are asking for the 3000 something, and then or what, like like at the end how many seats fully I can use, like if I'm using 42, 3000 something and 80, what is the limit of the seat? Like I don't completely understand what the seats mean.
I'll start with the first question about faces. So we use them because it speed up training process. Like if we start from scratch, like you can start training style GAN with just your data set without any pre-trained model, but it will take 2 weeks to get the proper results, maybe sometimes more than 2 weeks. And 2 weeks in collab, it's a real disaster. You'll be really tired in the end because you have to monitor the process, and also you have this 12 hours limitation, and sometimes less than 12 hours. These 2 weeks will stretch into a month, I guess. So this is why we use pre-trained model. And the seeds are some kind of addresses of the images in this latent space, in the space of GAN's knowledge. Yeah. So when you type 42, it means please generate me the image that are in the address of 42, or if you type any other number, it will generate you another one image. And the biggest number for the seed is, let me check, it's a really big one. Actually, you can look this number in the code. I can share the screen and show you. You can find the largest number. Yeah, if you go to this generation cell, generate images, and double click on it, you will see all the codes here. And here we have this parameter gen random, generate random images. And in the code, it checks if we checked this checkbox, then it will generate random images. And the maximum number that it can generate is this, I don't know, it's big, 4 billions and something. Yeah.
But the seeds are, so the seeds means that we are asking to the machine to give us back these images, the 42, well, not, yes, like the one that is in the object, and the 2, the 3000 something, and then the 80.
You also asked how much images we can generate. I guess it is limited to the space, free space on your Google Drive. So you can provide as much as you can. And if you generate too much images, it will say, I don't have any free space on the drive.
Interpolation part, like, for example, my video is have like 10 seconds. That is because the amount of frames or the images also I decide, or how can I make
I just updated this part because I found errors there. You can set the amount of frames, and there is two sections where we generate these interpolations. And in one case, we generate it from seeds, and then it's 1 second between each pair of seeds. So if you put more seeds, you will get longer video. And the second cell will generate. You can define the exact amount of frames, but we will talk about that later today.
Thank you.
Any other questions?
Yes, hello everyone. Do you hear me well? I had a question because I got stuck on the second collab we did yesterday because of the thing that there was a space in the definition, which I uploaded again, and I was running the code, but I just wanted to know, is it normal for it to take like, I don't know, maybe around 3 hours for it to generate the output?
Yeah, I also have the question about it.
So it takes 3 hours to for one tick, or for generate like for the training process.
Oh, sorry. Yes, for the training process to get to the final result.
Mm-hmm. I understand correctly that you get the results, the proper results, in 3 hours, or you you have to wait 3 hours between each tick that appears there.
No, so actually I started running the final results today, about 3 hours ago. But I was because of the new code that you gave us that allowed the spaces in the file directory, right? So I was wondering if is it normal for it to take so long, or how much should I be waiting before knowing that something is going wrong?
I guess it's normal because sometimes this training process takes up to 6 or 10 hours.
Okay, thank you.
It depends on data set. So you have to check the results folder from time to time. There you have this fake the images that called fake something.png, and you can check the results. If it's good, then you can stop.
Actually, I tried this training for twice, and I see the output of the results, and try the result to the third code that you provide, and I think the output is not good for me. And the last try of this training, and it said the runtime disconnect and it reaching its maximum duration. So I don't know, maybe I don't know what happened.
Runtime disconnect can disconnect when you didn't check the browser tab from time to time, and it disconnects. And also there can be errors that you reach the limit of GPU usage, like it will say something about GPU. I don't remember the exact text of this message. Yeah, so if it's just runtime disconnect, then the only solution is to check your collab tab, browser tab, like every 10 minutes, maybe. Yeah. Unfortunately, this is how collabs work. Yeah, and if you reach the GPU limits, then there is a way you can create another Google account and start like continue training in another account.
Okay, thank you.
Yeah, there is also Google Colab has a pro version that costs something like $9 per month. It still has limitations, but not not that short. So, and yeah, it works a little bit more stable, and you get better GPUs. Yeah, maybe you can try this if you want.
Okay, thanks.
So yeah, I have a question about the training process. Is there a set amount of tick that it's supposed to reach, or how is there a way to know? So I understood from the previous question that there is like a limit to the training process, and is there a way to know how far we are, or?
So from my practice, the good results starting from 7th tick and later, and it depends on data set. So sometimes it's 7th tick or 10th tick. And anyway, if you reach the limit, you can continue training later and get better results later.
Yeah, so it can train independently.
Yeah.
Okay.
You just have to wait some time before Google Colab will allow you to again.
Yeah, sure. But it's up to us to decide when the training has reached a level that we think is satisfactory. Okay.
Yes, that's why you have to check these images.
Yeah. Okay.
Anyone want to share your results? If you have some.
Yeah, I didn't start I didn't do any generation yet. I didn't use that last notebook, but yeah, I used a set of images that I found on what was the name of the website on Kaggle of satellite images, and so it's been training since yesterday. But yeah, it's hard to decide if it's hard to evaluate how well it's been trained already. So yeah, I guess maybe I can just show the latest snapshot and compare it to the real one. If that's something that can be interesting, I don't know.
Yeah, it is interesting. Yeah, I think the way how you can decide is like compare different intermediate results, and if you see that the details is like it's like the process when you get all the small details that like correspond to your data set, and then these details start to degrade or disappear, and you have to find this point when you still have them, and like the best the best resolution of it, and so you just need to compare.
Okay. So do you want to see the images that I've got so far?
It would be great. Yeah.
Yeah, I'll try to share my screen then. So this is the latest one. Yeah, I'll show the original one, which is this. So I have a set of about 300 images, I think. Satellite images of ice. And this is the latest result, which I am not sure I can still see some faces, but it's definitely not as interesting as the original, I think.
Yeah, I guess you could train for a couple more ticks, and it will be good.
Okay.
Yeah.
Okay, cool.
Thank you.
Hello.
Yeah.
Can you hear me?
Yes.
Yeah. Actually, I have a question. When I was training for the second section, so it's like having all those ticks, and when I stop, say I'm having like take 3 or take 4, then I stop the programming. Then it was like having this PKL file in the Google Drive, right? So if I wanna like continue to training that, it starts a new like folder in the Google Drive.
Yes.
So is that normal, or it's supposed to do that, right?
Yeah, it's normal. It's just saves every run, every training run in different folders, just to keep like this training separately. But it continues the previous one.
Yeah. Thank you. Then maybe I can show my training result. Yeah. Let me share my screen. I think I just opened too much pages here. I'm not sure which one is which. maybe this one. Yeah. So I was having a data set from Data Search, the website you were providing, and it's like so this is the real one. It's loading. So it's diatoms, those kind of algae in oceans, and this is what I got now. It's like 6 or 7 rounds after.
Yeah, that's great. I think it's already great. Maybe
Yeah.
two more ticks and it will be good.
Mm-hmm. Yeah, so I haven't started any generation like for the third notebook.
Yeah, we will do it today.
Mm-hmm.
I think I can show some, I did some generation, but I used my own images and I only used like till tick 4 because it was taking too long. It was like 6 hours already. But I think I can show it because it looks funny. It still involves the
sometimes
faces.
Sometimes collab working very slow. I don't know what caused this. Yeah, sometimes it helps to restart the notebook and train. Yeah, but like this, like.
Yeah, I just thought it looks very funny because basically it's faces and bacterial cellulose, so it's kind of ugly but pretty at the same time.
True. Yeah. Anyway, you can continue training after this class, yeah, and generate something tomorrow. Yeah. Anyway, it looks great.
Hello, you hear me?
Fine.
Yeah. I would like to share on my work, and I have one question about the. Let me see. This one. Yeah. I don't quite understand the truncation. What does it mean when I try to generate it? I don't understand. I just mess with the number, and this is my result. Fake this one. I use the I just download a right what no. This one. I use the.
Are you showing the video now? Because we see the folder. We just see the folder.
Oh. Wait a minute. This one. Okay. Yeah, you can see it now.
No. Yeah. Now you can see the images. Yeah, it's
okay. This is the Stella cluster nubile. I just downloaded from Pinterest and train it. It take quite long. It took about half an hour per tick, and now it takes 15.
Yeah, I think it's good.
Yeah, and I generate something, and I don't quite understand about the truncation. What does it mean? And
so
it's quite
the truncation, it's like variability of the images. I don't know how to explain it clearly. Like I understand what it is, but it's really hard to explain. Like we have this multi-dimensional latent space with all the images, and in the center of this space, I'm oversimplifying this, but it's the way how you can understand. Yeah, so in the center of this space, you get the most average image of the data set. And the truncation, when you set truncation equal to 0, you get this image. If you set truncation more than 0 or less than 0, then you get more variants of the generated images. Yeah. So the bigger this truncation number, the more strange images you get, because the most realistic one is closer to this average image. Yeah. So usually people set this from 0.5 to 1. Yeah. From my practice, usually the best is in this range. Yeah, and when you get more than 1 or less than -1, you get more abstract images there. Okay. This is how you can imagine what is truncation.
Yeah.
I hope it's clear now, more clear.
Yes, yes. Thank you.
Okay, I'll show you my one.
Mm-hmm.
It was my own data set. This is a waste plastic measured in millimeters, which becomes a habitat and a gross environment for marine inhabitant and different microorganisms. This is the real images. This is the final result, and actually I spent also 3.5 hours.
Yeah,
it was like 5 iterations.
Yeah, it looks great already, but we still can see faces. Yeah, so I guess you should train it more, like maybe 3 or 4 more iterations.
And I also want to ask you, it's currently training, and should I interrupt it?
Yes.
Right now to start another one.
Yeah, we will work with 2 notebooks today, with generation notebook, and it will use GPU. So this is why you have to stop. Or either if you have another Google account, you can run it in another browser with another Google account, so you can continue training in the meantime. And the second notebook will not use GPU, but we can use it only after the generation.
Okay.
Great. Anyone want to share their results? Well, then we can go to the generation notebooks. Yeah, I will send the link to GitHub again, just in case if you forgot where it is. And I will share my screen. So yeah.
This new GitHub you're sharing is with the notebooks are different from the ones that we were using yesterday?
It's the same as yesterday. I just updated this generation notebook, and I had already two image to point cloud notebook. We will use this one with one because it's more fresh. Well, let's start. Yeah, so I paste this path to GitHub, and now I'm loading generate notebook. Yeah, first I need to mount my drive. Well, first you can save the copy of this notebook. I will not, because I already have it. Then mount the drive. Yeah. Then we will install GAN, and we also need the libraries. Yeah, and we can skip this step because we will use our own models. They are good. Should I go through the first cell that we already did yesterday, or we can go straight to the interpolations? How do you think?
I think if you can go just quickly through the first steps, like might be helpful.
Yeah, okay.
Thanks.
So yeah, the style GAN is installed, and now we can generate images and videos. And the first cell that's called generate images is just for images. Here we provide the path where we want to save our results. I'll call it something. Basically, you can find the folder where you want to save it on your drive or somewhere else. I will save it here. The results folder. I will copy this path, paste it here, but I will add another number because I already have the folder 1 and folder 2. Now it will be folder 3. In the next field, you should provide the path to your model that you trained. So you can find it in collab with G2 other PyTorch, and then you should open this folder, and there you have results folder, and you should find the latest folder here and the latest network snapshot. I will not use mine because I stopped train very early, so I will use another model that I already have here. But you should copy the path to this snapshot and paste it here. Yeah, well, then you set the truncation parameter. I already explained what it is. And the next one is seeds parameter. We already talked about this today. It's just like addresses of the images we want to generate. It's like if we provide this 42 and generate the image, and the next time we we decide to generate image and provide the same number, we will get the same image. So this is how we can generate a lot of images, then decide which one we like, and use them later in the interpolation videos, for example. Yeah, so I will keep it like this, these three numbers. So we will generate three images. But also, if you don't want to type all these numbers by hand, you can generate random images. Then you have to click here on this checkbox and set the amount of images you want to generate randomly. When you run this cell, the first output will be the numbers that was generated. So later you can use it again. Yeah, so I will use these images. And the last section of parameters is the way how we can generate non-square images, like default, by default, style GAN is learning to generate square images, but we can override it here. So you just need to click on this checkbox, set the width and the height, and also there is an option how you will fill all this space, because by default style GAN generate just square piece, and it generates multiple square pieces and somehow put them in this non-square image. So this is the option how it mixes all these images. You should test it with your data, because it's always different results for different data set. I will keep this default option, and now I can run. So yeah, I see the number of the name of the seed.
Sorry, Arkan, this can change if we put other kind of seeds like we were talking about. We can have like more that like our interpolation video be more longer, or we have to change the seeds in the interpolation cell or here.
Yeah, we can set any amount of the seeds and any numbers we want.
Does it make like the process be like slower, or does it affect in any way?
Yes, the more seeds we will have, the longer it will take to generate the image, all images. Like here we just generate three images, and the longest part is loading the model, and then the images will be generated like in 2 or 3 seconds. Yeah, it's already done. And when we generate these truncation videos or interpolation videos, we will get more images, like several hundreds of them, or sometimes thousands if you want to generate long videos. And it will take time, but we will check it later. Yeah, so we just generated 3 images, and we can check it on our Google Drive. So yeah. I have it here. And in the results folder. So here I have 3 images. First one. second one, yeah, and the third one. And I guess they are the same as yesterday. I can go to the yesterday's folder and I will try to find, I don't have it. I don't have it because I generated another images. Yeah, there's another model. Anyway, it's also good. Yeah, I also have a comment on these sizes. If we generate non-square images, it's better not to generate images that are 2 times bigger than the size of the training images, because it starts to produce very weird results. It's not what you want. So, like for example, I have a model that was trained on 1024 pixels, and the highest dimension has a little bit smaller than 2 times. Yeah. So this gives me a good result. We can try this. Generate one more. And I will set like 4,000 by 3,000, for example. Let's check what we get. We need to update the folder. Yeah, here, the new image. Yeah, it's loading slowly because it's big. Actually, this time it's good, but you can see these patterns. It just repeats the same image every time. Actually, this is what you can change by changing the last parameter, this scale type. So if I check this theme, I will get another result. I will generate one more image just to show the difference. Yeah, and I think this theme is theme parameter is less stable than path, but sometimes it generates more interesting results. Let's check. It's still running. Yeah, you can check if your notebook is still running some cells by this icon on the top. If it's gray, it's still working. When it will be orange, means that it's already generated something. Yeah, like now. Yeah, the new file. Yeah. Yeah, you see, there is not that strict pattern, but it's still repeating, and it's not very great, I'd say. And but if we use the same scale type but lower resolution, it will be better. Like I'll go back to I'll set another seed, just not to overwrite the image. Also, it takes more time to generate non-square images than square one, but it's more or less comparable. One. It's, I think it's much better. The structure is here. Well, let's go to the next cell. Like, I recommend you to play with this cell before you generate the interpolation video, so you will understand what kind of scale type is better for your data set, what kind of truncation value is better for you. And also you can choose the proper seed, like you can generate lots of them, like hundreds of them, and then choose 10, for example, the best 10. And use them to generate interpolations. Well, anyways, the next cell is where we play with truncation. Here we have almost the same parameters, except we should provide only one seed, because we will look how it change with different truncation values. And instead of providing just one truncation value, we will provide like the range of it, and we should define the starting point and the end point. So we can, I will set that we will start from -1 and go to 2. So we will get different results, not only realistic one, but also some weird. And I will set the increment, the step, to 0.1 to get get the results faster. But if you set it to 0.01 or 0.0 or even less, you will get smoother results, because you will get more steps between each pair of images. Yeah, and here we will get 30 images because we have from -1 to 2, and with step 0.1 is 30. Yeah, this cell and interpolation cells, they not just generate images, they put the generated images into the frames folder and then combine these frames into the video. So you can check the individual frames, but you also can watch the video. So I will go. I forgot to change the results folder. So I need to find it on my drive. I think it was here. And the folder number 2. Okay. Yeah, here is the video. Yeah, change. I set a small amount of steps, so I get only 30 frames here. But anyway, we can look it like this, like from -1 to 1, we get more or less realistic results. We have this cell structure, and I guess somewhere here we have the most average image, and you can see that it doesn't change a lot here, where we have more or less close results. Yeah, but in the end, when we get the truncation value more than 1, we get these strange color blobs, and the cell structure is already gone. So I guess you should check which parameters is good for you. And yeah, now we can go to the interpolation videos. What is interpolation? It's when we provide 2 seeds and generate 2 images, the algorithm tries to reconstruct the steps between these images, like how it could look like if we mix them. And here we should provide clear the output, so it will be easier to navigate a notebook. Yeah, I will copy this result folder. Yeah. So we should provide all these passes to save the images in correct place and to run the proper model. We should set the truncation, and then we should set the seeds. So for each pair of the seeds, it will generate 240 frames. And yeah, I will generate like 3 seeds, and then we will get longer video. Yeah, and also we can make it make a loop. So if we check this checkbox, it will add the first seed to the end of this list. So then we will stop with the same image as we started. I recommend to do this. So in case you generate not a very long video, you can play it on the loop. Sometimes it's very helpful. Like it's easier to generate like 2 minutes video than 20 minutes video, and just to loop it. Yeah. Also, you can generate random images, and it will make interpolation steps between these images. Yeah, also we have different parameters, different algorithms how we can interpolate between 2 images, and the easiest way is to make this linear interpolation. It just will like if we imagine this multi-dimensional space and we find there, like we define one seed and another seed, it will just go from one seed to another and generate um, 240 images that are between these two seeds. Another option is slurp. To be honest, I don't really know how it works, but it generates more smoother videos. And also there is one more parameter is which latent space we use. That latent space is the like all the variants that the style GAN learned from our data set, and W space is just those that look like the original images. So if you want to make your video or your interpolations look more like your data set, you should use W. But if you want to get more variety, then it's better to use that space. So I will generate two types of this, or maybe even four. Yeah. Also here we can generate non-square images as well. And for the next step, like when we will generate point clouds, we should make non-square images. But for now, I will generate these square images just to show the difference between different types of interpolation. So first we will run this default parameters. Yeah, so it says that it has to generate 480 images. It will take some time, but I guess we should wait. Yeah, while it's generating, I can explain the next step, and we'll do it later. Yeah. So the next step is generating the loops. Like here, we just generate interpolation between each pair, and we can loop it by providing the last number. It is the same as the first one, but here it generates loops automatically, and it generates just random images from the whole latent space. And we have two types of such loops. One is noise loop and another circular loop. Noise loop is absolutely random images, and sometimes it's like not very interesting to watch that kind of videos, because it's just blah 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 blah. And circular loop generates more smooth videos, and the images change very smoothly and interesting manner. Also here we can define the amount of frames. So, and also we can define how wide is this loop, so how much images, it will like how far in the latent space this this algorithm will go. So the larger the diameter, the more random images we will get, more different images we will get, and also we can work with these two parameters together. The larger the diameter we will set, the more fast video we will get. So if we set like a small diameter and large amount of frames, and the video will be slow. If the diameter is much more than the amount of frames, the video will be fast. Yeah, all other parameters are the same as in previous one. Well, we're still getting the results generated. Yes, it's for this 370 images. I will find the intermediate results just to check, just to show what's going on there. Yeah, you can notice the difference, like when we generate just single images, it saves it in the folder we set, but here it creates the frames folder and saves the frames there. So if I go through the images, I can see that each image like changes very you know, slightly changed, and like I guess we can wait till we get the video to see the process, but even now we can see that we get almost the same result, but it changed a little bit, and yeah, and this is how interpolation works. Yeah, it's already generating the video, and we should get it here. Yeah, there it is. Let's check what we get. Yeah, you can see how this structure is moving and changing. Yeah, and if we compare it with truncation video, there is more or less the same structure, but it changes from real image to something unreal one. And here we always get something close to real images, but it constantly changes from one to another. Like see if we look where we started and what we get, it's just two different images, but the changes are smooth. Well, I will also generate. We have not much time left, So I propose to you to check other other interpolation options after class, and I will show how the loop works now. Yes, so I'm looking for results. Yeah, that results folder. Yeah. And I will generate circular loop, and I will use this result for the next step where we will generate point clouds. So I will keep 700 frames, and I think I should set the bigger diameter, like something like 1000. Yeah, and I will generate non-square images with the fun options. Yeah. Yeah, now it's generating. Maybe while it's generating, we can discuss. Maybe you have some questions about this process. Maybe you try.
Honestly, I have a question.
Yeah.
So in my pre-trained model, I can find a file pkl.
You cannot find this?
Yes, I can.
Okay. So it should be in this collab sg2 other PyTorch folder, and then you should go to style GAN to other PyTorch, and there is results folder. Maybe I can stop sharing the screen and you will share yours, and we will do it. We will find your.
Yeah, sure.
Yeah. Let's proceed. Yeah, so there is collab. Yeah, this folder, and yeah, that was the right folder. Go there.
This one?
No. I don't know. This collab sg2 other PyTorch. Yeah, this, and then you should open this. Yeah. Results. And this one. Wow. You don't have it, and it's strange. You didn't delete it?
No.
It's very strange because it maybe the reason is that you don't have free space on your drive. It's like you have
maybe.
Yeah, so it has you have enough space to save the intermediate images, but not enough space to save the model itself, because the model size is something like 350 megabytes, and I think did you
okay, I'll add a space after we finish. So, but it's not because I finished, because I interrupt my previous
no, it's not
correctly.
Yeah, it's not because you interrupted it, it's just because you don't have any space to save the model. Yeah, it's a pity we didn't check it before you stopped, because we could free some space and you will save the results, but right now I think you have to retrain the model.
So I have a question. I don't know if it's just me or everyone. When I in the interpolation cell, when I try to switch interpolation from linear to slurp, it's error. Says about something about CPU or what. I don't.
Can you share the screen? Let's check the error message.
Wait. Can you see it? Yeah, can you see it now? NumPy has no distribute CPU.
Strange, why want to use GPU? Okay, I will check this, and I will update this part after class.
And another question, what is the function of amount of random image? I try to change it to 15 and I see a lot of
yeah, you should check the checkbox right before that, GAN random.
I see.
Then it will work.
Okay, I see.
They work together.
Okay, thank you.
Well, I will share my screen. So I just got only 275 images, but anyway, while it's generating, I can start with the next notebook. So yeah, because it doesn't use GPU. Yeah, for now, the name is inks to point cloud 1, but I guess I will update it also after this class, and it will be the same name as this one, but right now I will use this one, just not to make mistakes. So in this notebook, we will use the results of interpolation generation and use it to generate point clouds. I will show you an example. Something like this. We will use each image, each image from this interpolation video as the layer in our point cloud, and we will get some structure like this. And we have this pores here and the structure of cells. I will show just another example. There's a square one. There's a square images. It's something like this. And later, like tomorrow, we will work with Maria on these models. She'll show you how to process this and do some interesting results. Yes, so here we should load the libraries that will generate point clouds. Yeah, then we should add the functions for point cloud generation. Actually, it's just take each image, then convert it to grayscale, then make a threshold, so we get black and white image. So this is how we get this structure, this cell walls or something else. And for those points that have black color, we will make points in point cloud. Yeah, so after I added these functions, I need to mount my Google Drive just to work with some folders. And I guess I will not wait till it generates all the images and just start with those we already have.
Can I ask you something?
Yes.
We have like in this new link, GitHub link for these files, and which is the difference between, because both files that have like emds2 point cloud, we have two files, and which is the difference between each of one, you know, like I just opened and they have like different cells, like the notebook looks different, but does it have like two different functions, each one?
Sorry, I didn't understand the question. Can you repeat again?
Yes, like you shared these two files, these two new files about the using the point cloud one. But we have two files with the same name, and they have the two notebooks with the same name. You just
yes.
So which is the difference between each one? Sorry.
This one with the one in the name is more fresh. Like I changed some, I fixed some errors there. So you should, for now, you should use this one.
Okay.
But I guess after the class, I will merge them into one file, and the name will be just like this.
Okay, thanks.
And I will remove this one. Yeah, sorry. It's just some mistake. I just saved it with different name. Yes, so yeah, we already have almost 600 frames. Maybe I should wait till the process is finished just to get a nice result, not just half of it or part of it.
I have a question actually.
Yeah.
So when we are like having those frames, does that mean if we are having more frames, the model we are getting from this session will be like thicker, or it doesn't matter?
Yeah, it will be thicker, but we can control this. The size. Yeah, I can show you the next notebook, and yeah, here we have some parameters like we can skip every like some layers. We can take every image, or we can take every second image, and so on. This is how we can change our model. Also, we can take not every point in the layer from the image, but every fifth or every like any other amount that you set here. I added these two parameters just because if we take all the points from the image, it will be very huge point cloud, and sometimes yeah, the model can be like 5 gigabytes or something like this. It's too much. And the distance here is the distance between two layers. Like if we set one, then we have like very dense model. But if we set it, if we change this parameter to the bigger numbers, we will get some free space between each layer. So if we want to make a very thick but not very dense model, we can set it here. And yeah, we also set the images directory. So it's where we saved all the frames, and also the directory where we will store the results. And here we can name our point cloud file. So yeah, actually that's the all parameters we have.
Sorry, I think I'm not understanding. What do you mean with this point cloud, or what does it mean? What do you mean when you say like there that if you don't want to generate new images with the GAN and you want to create a point, like what does it mean?
Like point cloud is kind of maybe 3D models or 3D representation of something that are coded with points. And here we have like the source to place these points in three dimensions is from the GAN images. So like if you look here, you can see we have a square model. It's like our generated style GAN images. And it's like have something like 720 layers. We cannot say it from here, yeah, but if we zoom out, we can see. And yeah, each layer here is just one image that was generated by the GAN, and as we have these images, they are slightly changing, and so we have the structure is also slightly changing, so we can see those pores, and the cell walls is also changing from layer to layer. So this is the way how we can generate 3D model of the wood. For example, like in our case, we have the model trained on the cell structure of the wood. Yeah.
Okay, thanks.
Yeah. Yes, so now we have all the frames generated. We can check the video and what we will have. Actually, it's here. No, I think it's something old. Because, yeah, I should find the proper one. Yes, it was generated, but I didn't process by Google Drive. So, yeah, this is the correct one. Yeah, it's non-square, and it has these structures there. Yeah, it doesn't look very nice in some parts, but yeah, I think we should experiment with this the last parameter where we set the scale type. It will affect a lot, but anyway, we can work with this video. Yeah, I mean, here we have these patterns that are repeating, like the image is sometimes very symmetrical. This is because I choose the path type. Yeah, so now when I have all these frames, I can generate the point cloud. So I'll go to the next notebook and I will set parameters. So I will take every image and I will take every fifth point on these images. And yes, I'll keep the distance 1, so I will get that tenth model. And the image directory is the same like in this notebook where we store the results, but I have to add frames here, so it will take frames. And here is where I will store the point cloud. And I will call it point cloud just like non-square. Yeah, so now it loads the images and process it to generate the final output. Yeah, it says that it will take around 25, 26 minutes. Yeah, I guess we should wait for it. Or no, I think I will stop this process and we'll skip some layers just to make it faster. And now when I take every 10th image.
May I ask a question?
Yeah.
Did we select through 721 frames for a specific reason, or we can put more with them?
Yeah, you can put more. It's just the default value I set up because 720 images is like if we divide it by 24, it will be, well, it's just some maybe 30-second video or something like this. So if we have 720 frames, yeah, it's exact 30 seconds.
Right.
Video. And this is why I put this number, but you can change it in any way, and you can make it smaller or bigger. So it will affect your final model. The more frames you have, the thicker it will be. But it also will take more time to process it.
Yeah, thank you.
Well, it's almost there. 20 seconds.
So you are using it here right now, like one frame, like the 721 one, or you're using all the frames and like mixing up to make this kind of 3D mesh?
Right now I said that I will take every 10th of these images, so it will be 72 layers in the final 3D model. So it will be smaller. So yeah, I can show you the result. Well, I put the wrong path again, so I travel across my Google Drive. Yes, here we have point clouds. Yeah, I will download it. Google Colab doesn't have any viewers for point clouds. Yeah, now we can check what we get. So again. Yeah, you can see I have this strange model. Yeah. And if we compare to the previous one, I will open it later. We can see that we have less amount of layers. We just skip some of them. So it's not very dense, but the overall structure is still there. So it's like,
Artem?
yes.
Are we keeping the attribute of the color?
Yeah, we keep on the colors from the style GAN images, but only for those points that are was saved. Like you can see, we don't have all the points there. Like it's not just an image stuck one on top of each other. Yeah, so this is yeah. So if you have colorful images, you will get colorful models as well. Yeah, this is the result of this. And I guess we still have some time, and we can go through the interpolations if you want, or you can do it at home and ask me if you get any questions. Because as we revealed, I have to fix this slurp interpolation. Actually, I can check it right now. Like if I have the same error. Let's generate interpolation. Yeah, the same. Yeah, I guess I will have to look at this. It's not like the error in my code, but it's an error in the code that is goes with style GAN. So I will need to reveal what causes this problem. And also, I will check the W space. We didn't check it. Hope it will work perfectly. Yeah, it works good. Actually, there is not much difference between Z space and W space when we generate these abstract images. I guess it's more like you can see the difference when you generate more like faces or cars or something like that. Some objects that we usually see in everyday life on this microscopic or macroscopic levels. That it will not affect a lot. But we can check already. My drive. Yeah, the same cells as in previous run. So it depends on the data set when you should use Z or W space. So you should experiment. But usually this gives better results, the W, while Z will give you more variable, yeah, different images there. Yeah. We almost get the video, so you need to check it, and I'll show you also the noise loop. So we generated circular one. This one. Now the results is a little bit different. Yeah. This is with Z space, and this is with W space. I guess we have a smoother video. Yeah. It doesn't change that much when we use Z space. Yeah, the last thing we didn't try during the class is this noise loop. Let's save it to this folder number 7. Yeah. Yeah, and if I'm not mistaken, both noise loop and circular loop, they work with Z space. Yeah, here. Because it gives the more, yeah, the bigger amount of different images.
Artem, I have a question.
Yes.
So what's the objective when you're varying all these parameters? What are you looking for actually? Like, do you have something in mind, or is it in terms of the investigation you're running?
Mm-hmm. Well, it depends on data set. Yeah, like in this case, I'm looking to generate the more like the structure that looks like wood, that has all these cell walls and so on. So actually, yeah, it's just an experiment, and I just change these parameters and look on the results if I satisfied with it. I cannot explain it like in rational way, yeah, because it's always like the feeling like this is what I want. Like for example, if we change this diameter, we will get slower or faster video, and the images will change faster or slower, and it gives us different structures in the end. And I just check if this structure is good for me or not, and so on. If we generate some I don't know, not that abstract images like cells, but some faces, yeah, then we can, then these parameters will affect how this generated face will look like. Because when we talk about cells or other microscope images, it's hard to say if it's looking like real one or not if you don't look into the microscope every day and know all the features of the real microscopic images. So yeah, for now it's just feeling if the generated images are good or not.
Okay, thank you very much.
Atam, I want to ask you about the notebook, the image to point cloud, the cell which is take every number point in layer, and what does it mean? It so each layer it take 5 points or what?
Yeah, it's like you have an image that is 1024 pixels in each size, for example, and it will take not all the 1000 points, like each pixel is a point in our case, and it will take not each pixel, but every fifth pixel.
Okay.
Like I will try to show it on the model. Like here, if I zoom in, I can see that there is some small distance between each point, and this distance is 5 pixels, maybe. Yeah. Sometimes it's different because sometimes it's skip some other points. That is not possible. Like here in this part, I don't know. I'm not very good with 3D programs. I'm more coder than modeler. But you can see that we have distance between points. And if we put 1 here, it will take every point, and this model will be denser, so we will not have this like distance between each row. It will be like very dense, every like no free space here.
And distance between layer is the height of each layer, right?
Yeah.
If it.
Yeah, it's the height of each layer. So it's how far each layer from each other.
Okay. Okay. Thank you.
Adam,
Mm-hmm.
I have a question about the interpolation and the interpolation loop.
Mm-hmm.
Like we have the loop option in the interpolation like cell.
Mm-hmm.
So what's the differences between these two loops?
The difference is that in the last cell where we have interpolation loops, the frame we cannot control the frames. It just generates random frames, and we just can control this diameter option, and it will generate more random or less random images. But we cannot control exact frames. And here we can set exact seed, so it will generate those images, like those images that correspond to this seed, and it will generate the intermediate steps between these images, these interpolation steps. So this is how we can control the final video. Like if you want to generate not just random interpolation video, but you know which images you want to see in the final results, you can provide these seeds here and generate the video you want, not just one.
Yeah. Thank you.
So if we change that seeds, like you have there 42, 3,000 something, but 300 something, but you already told us that in the code it says that we can go further, like 4 millions or for like
we can put here 4 millions like this, and it just will generate another one image.
It means that it's here. My question is that here is going to make like three images, right? But if I use like, can I say that goes from 300 to 4 millions, and that will help my video have more frames at the end? So, or it's better just to generate like three or two pictures and then work with them in the interpolation parameters to play with the result, the video result.
So yeah, it will generate like if we set 3 numbers here, it will generate 3 images and 240 images between each pair of these images. So this is how we can change the length of the video. Did I answer your question?
Yeah, sure. Thanks.
Yeah.
I have another question about when you already I already made like with the point cloud, and I have this PLY file.
Yeah.
Well, like with what kind of program, like Reno pick up this kind of files, or what other 3D
Yeah.
programs load this kind of files?
I use MeshLab because just to watch these files. You cannot edit it here, I guess. Maybe some very basic operations. So I use it because it's free and it's cross-platform. But you will work with these files in Rhino and in Grasshopper. I guess I'm not sure if Rhino works with point clouds, but Grasshopper works for sure. Yeah. But I'm not. I don't know if Maria is here. I guess she.
I'm here. Yeah. Yeah, but I missed the question. Sorry, I couldn't hear it.
Well, the question was, we generated this point cloud, and we will work with it in Rhino. Yes.
Yeah.
Rhino.
Well, yeah, the plan is to work in Rhino Grasshopper, and that's why you need PLY file. And basically, PLY could be directly imported to Rhino, and that's fine. Just be sure that you have quite a powerful computer. I was just now working in the parallel and missed maybe a few points. Artem, when you are generating the point cloud, are you showing to the guys the dense kind of high-res point cloud, or the control?
I explained this model, these moments like.
Okay, it's keeping points. Okay, yeah, I see.
So maybe you can comment on this. So it's better to make as dense as possible. Yes.
Well, it all depends on your laptops and computers. So if you are sitting next to the kind of computer station and capable to handle some heavy files, I think that will be okay to have a dense model. If you're just working with a simple laptop, and which is, well, if you're working in Rhino Grasshopper, by the way, can you raise the hand who is working in Rhino Grasshopper? You can raise physical or virtual hand. 1, 2, 3, 4, 5, 6. Okay. Okay, so basically we all kind of know. I don't need to give the intro to Grasshopper or something. No? So you could already, for example, today, while you're generating the point cloud, you can just import. If you go to File, Import, you are selecting the PLY file and it's importing it into the Rhino. And you can see how it behaves. So if it's handling it, that's fine. Also, if you're working in Grasshopper, you could do like start maybe some manipulation of attaching, going to the Volvox. We will be working with the Volvox now plugin. Probably I would need to send it to you. Please install the Volvox plugin. We can go through it tomorrow as well if there will be any problems, but basically if you go to in Grasshopper to the special folder and drop the Volvox installation files, it will be on your Grasshopper interface, and you can just double click, type point cloud, and drag assign the point cloud to Grasshopper, see how it works. So I was working in both resolution, in the lower and the higher. My computer handles that, but let's see what you have. I would suggest you to prepare two, maybe. One is a bit denser, another one is lighter, and see how you can work. But also it will depend, the result will vary from the resolution of the point cloud. So we will do some simple steps. I don't want to overwhelm you with Grasshopper, because I think, well, you should be quite familiar with that, but just I will show you some ways that I'm using to go to the, for example, voxelization and work with the meshes. So, and then set up the drawing. But yeah, that's basically up to you. Try several options, check if your Grasshopper is handling it, or we will see it together tomorrow. Not tomorrow. We have a class the day after, I think, yes? Yeah, the day after tomorrow.
Maria?
Yeah.
What kind of plugins for Grasshopper do we need to have? Like, I'm working with Mac, so maybe there are some of them I couldn't have, or...
Do you think you could install the Parallel to your Mac?
Yeah, I'm trying to do that. Maybe I can do that tomorrow somehow.
Yeah, Volvox, I just type it here. And I think we will also need Mesh Edit. That would be nice that you have. And I will send you the list, the full list. I don't remember what else is there, but for sure you'll be missing it in Mac. I can show you two options. Maybe one will be a bit easier, and maybe Mac will have it, but it won't be working with the point cloud. It just works with the image. But if you want to continue in your practice working in Rhino Grasshopper, I just suggest you to do it now, because you won't avoid it. Unfortunately, we still don't have all the plugins for Mac, because, well, you imagine the developers of the plugins, they are same guys as us, doing some stuff, developing these things, and they've done it like, I don't know, 5-10 years back, and they've done it for Windows. To make it for Mac, they basically need to make some effort of rewriting it for another operation system. So they just don't really want to do it, probably. So that's why, like, Mac is like working properly. Ryan is probably properly working on Mac, Grasshopper as well, but it's kind of empty. You know, it's like you can do things, but not a lot.
Yeah, I'll try to have a Windows then.
Try. I'm also working on Mac, but I have Parallel installed and I have Windows installed with the Bootcamp as well, and both options are working.
Yeah, thank you.
You're welcome.
Maria, could it be possible, yes, tomorrow or the next class to you give a small introduction about Grasshopper and stuff, because I'm not like so into it.
Okay, I will maybe make it short and entertaining for everybody. I will think something that we all catch up. And yeah, so it won't be the intro to Grasshopper, full intro to Grasshopper, but at least kind of a bit of the logic, how to work with that I will show, but also the algorithm, the definition that I will give you, you would just need to open it and work with that, and then we will have results, so it will be quite intuitive. So same as here, Artem prepared for you, not that, like, he didn't teach you Python from the start, no? You didn't need now to learn the basics of code, etc. So basically the code was prepared and he adapted it for you. So you just need to kind of read it, understand it, and press the buttons. So basically it's becoming a tool, an instrument that we share with you. But yeah, to start like understanding Grasshopper and Python, I would suggest you maybe to also check everything what now Digital Futures is doing. There is a lot of courses as well online who are just teaching the introduction to Grasshopper, and you can see it after all. There's a lot of genius people running it. So for your next steps, you could also just follow some simple exercises, and of course it will help you to understand both coding and visual coding, because the logic is very similar. It's just a code, it's a mathematical language that you need to understand the formula. It's all that is a math, and if you will understand the math of these algorithms, then you will be quite proficient with that. But I honestly was learning Grasshopper not in the way of understanding it from the beginning. I was learning it through doing. Like I was just faced to some hardcore stuff, and I started to try
I
to
learned Python. Just
yeah. But that's the way how we work with that, being architects and designers, because we don't want to spend probably a lot of time for learning tools. We just kind of investigate, and we want to have a result, and we're trying our best.
Okay, great. Thanks.
Hi, Maria. I was just asking also Arteman. I want to know. I was just interested in knowing what are your personal GANs, what you use it for, or in your professional life. What do you? I mean, what is the objective? So as to get a little bit of an idea when we're working and we're trying for the first steps.
Yeah, you mean specifically machine learning, huh? Yeah, so for me, and I was showing you in the first class, I was showing you some examples, basically the code that you are using, and Artem is showing you these examples of the wooden pattern. I'm using like this idea in my PhD in order to extract and learn the behavior and the property of the wooden structure and translate it into the design model. So basically, well, at the beginning, this video just looks funky and it's beautiful. But then, like, if we start to think and read the image, for example, converting it to the point cloud, as Artem just showed you, then we understand that we could basically rebuild it and start like constructing the model based on this material. And of course, it very much depends. Sorry for the noise. Of course, it very much depends on your creativity and your ideas and on the data set that you're using. So I'm using this wood to create this synthetic material. I'm calling it synthetic because it's not exactly like it's learning the biological principles, but creating absolutely fake results. No? And then you could think on the options how you could interpolate this material gradients over the structure, or how you could drive a design by redistribution of the material. And I think that's interesting how the material properties are starting to drive the results and the final shape. And I'm aiming in this basically to apply this heterogeneous property of the material. Kind of that's why we, for example, Artem, when he was explaining that it's up to you how like until which extent do you want to train it, when it starts to be kind of fakey and creating your abstract image, or you want to keep the structure of the wooden cell and kind of control it more. So in my case, I do want to control it because I want to keep this idea of the wood, and I don't go to the like a large extrapolation of the kind of fake images, which is also beautiful and could be also used as a design instrument. But yeah, I want to keep this idea. And well, of course, it doesn't mean that we are basically doing something absolutely biological, genius, and the breathable material. It doesn't per se means that. But what is interesting for me here, that in this method, we are setting up a strategy, a method for embedding the biological principles within the design process. Because we are so focused on the parametric design, we are so focused on these machinical tools, algorithms, they are done by the means of the machine, by the means of the digital kind of coding, for making absolutely artificial structures. So the idea of the reading and connecting to the environment, it can be as a design decision of the architect to do so. For example, at the end, to choose the material which will be less harmful for the environment. It's a design step, or to not place it next to the water, or, well, there could be, of course, much less primitive design steps. But this kind of an idea, this kind of ecological thinking, sustainable thinking, comes as an overlay over the design methodology. And I'm trying to convert it a bit and say that, look, basically at the background, as a base of this principle, we might think and look into the intelligence of the biological matter, of the biological creature, and start driving, like basically we are designing together with the environment, together with some bacteria that you are now inventing with the machine learning. So, and of course, it's a speculation, and we are not blind saying that now the artificial intelligence is creating a genius structures, avoiding a human brain, and the biological intelligence is purely kind of, again, genius and truthful. There's no truth in all this process. No, it's just that maybe a new design method, which also aims to create a bit of a different aesthetics, a bit of the different logic itself, and maybe come a bit further rather than parametric design, which is, maybe we read it all, first of all, maybe. And then, I think that parametric design tools are not answering all the questions now. So because all these parameters that we are setting up, basically maybe here is the question, how do we give this parameter? Who is giving this parameter? Is it us? Is it algorithm? Is it nature? Is it what? So that's how I frame my research. And I think that's anyhow targets also the aims of other authors. I don't know, maybe you saw a lot of genius lectures by Matthias del Campo. Of course, you need to listen to Neil Leach, and they are absolutely inspiring. Daniel Malonyan, who is doing right now also amazing workshop. So there's a lot of, and of course, I'm not saying you know everybody. So there's a lot of people who are investigating that, and I think somehow we all target the question about, like, kind of, we're trying to remove maybe a human role from the very center of a design decision, of the, at least for me, it's like that, of the design thinking, you know? And basically we are a bit reshaping this hierarchy where human is becoming the leader of the world and designing for himself. We are starting to think, what are the other agency? Now the agency is basically the acting kind of source, now acting mode, who is like becoming a part of the design process. So, and here the algorithm, the biological matter, and the human, of course, we are trying to act in a parallel. So we are simultaneously making a certain design steps, and we both, like three of us, are dependent on each other. And I think here is coming this kind of game, and this, that's how I do approach it. And but it's always great to do the workshops together, because it's absolutely open for the discovery, this topic absolutely open for the thinking. And maybe this would be great if in the final review, we will be inviting Claudia Pasquero to join the final review, and she is also a pioneer in this field. So I think that it will be great to open up a discussion and think together, how do we approach it? How can we drive these projects forward? What does it bring to the design question? What are we aiming to achieve? It's basically this kind of biocomputation, I would call it, the evolution of the biocomputation. And how would it change the architecture? How would it change the aesthetics that we are used to? And maybe through this process, you could discover absolutely new vision and design methods rather than we are proposing to you. So feel free to experiment. I already happy to see that some of you are taking your own database, some others are working with landscapes, some others working with biological creatures. So it's already great. And I also experiment a lot on that together with Artem. And so feel free to kind of bring your personal statement. We will be super happy.
Thank you very much. That was great.
Thank you, Delfina. So, Artem, did you finish actually, or did I interrupt you?
Yeah, actually, I showed everything I was planning to show. So, yeah. we have this discussion moment.
So I hope it was clear, and I don't know, we'll bring you to the next steps. Looking forward to see what you will have. Try to have this PLY file, keep the color of the point cloud. I think it's also nice to translate the color to your models.
And there is no way to get rid of the color right now. But if you want, I can add.
Don't do that. We will work with color as well, because I want to then manipulate the point cloud also depending on the color. And yeah, this, well, we will play. And also, if you are proficient in the Grasshopper, I will show you the definition, and please like feel free to modify it and also share with me. I will be absolutely helpful, because basically we are sharing the project that we are running right now, and any help from your side will be so good. So if you have any ideas how you like suggest us to evolve it, and of course there will be your authorship in this process as well in this case. So please feel free to suggest new options for Grasshopper, or new options for the machine learning, or new visions. And yeah,
it's always great to have this kind of feedback.
Yeah.
Notebook and so. Yeah.
Great. So I don't know if you have any other questions. I don't know if we went out of time. Probably no.
No, we still have time, but I think we have to experiment with the notebooks, with generation, and I'm not sure it's great to do it online. It's better to do it in our own pace, and you just feel free to write me if you get any errors, and I will write you when I'll update this notebook, this STORP interpolation, and something. Yeah, I have notes what I have to do with notebooks. Yeah, so
Super.
I will update it soon.
So please write us in the WhatsApp. So don't write the personal, because I might lose it, and we will be faster if we keep it organized in the WhatsApp chat. So we see each other in, if I'm not mistaken, in 2 days. I don't see my calendar.
In 2 days.
In 2 days. So you have a day to work. That was on purpose, to let you work a bit, and then next session we see the Grasshopper. Then we will have one review, maybe even, I don't know, like setting up the drawing. We will think in the last class how to present it, how to organize it. I might also show you some reference how to structure the presentation a bit better, how to collect different kind of shots of your experiments, and we will discuss it. Just we will set up the presentation, and then we have a final review.
Okay.
Cool. Good to see everybody.
Yeah, I wanted to join you with Grasshopper. I didn't do anything there like for ages, but I'm not sure I can do it on like in 2 days.
Well, if you can, I'm happy to teach you as well.
Yeah, I will watch it. I will watch the recording, and I'll try to do it by myself, and we'll join you on Thursday.
Not only as a juror, but also as a presenter.
Yeah, I want to participate.
Super. So thanks again, Artem. You are a host, so you would need to stop the stream.
Yeah, okay.
I don't have access to that, and I'm looking forward to see everybody. Have a lovely evening. Or a day, I don't know, everybody in a different part of the world. Morning, evening, day or night, where we are, I don't know, but have a lovely time of the day.
Yeah. Good
Bye-bye.
luck.